Hi friends, in this episode we will see about the important requirement for pump operation. The terminology and requirements we'll see now. Net positive suction head is a measure of the pressure experienced by a fluid on the suction side of the centrifugal pump. It is quoted as a head. It is measured in feet or meters. NPSH is defined as the total head of fluid at the central line of the impeller less the fluid's vapor pressure. The purpose of NPSH is to identify and avoid the operating condition which lead to the vaporization of the fluid as it enters the pump, a condition known as flashing. In a centrifugal pump, the fluid's pressure is at a minimum at the eye of the impeller. The pressure here is below the vapor pressure of the fluid. Bubbles are formed which pass on through the impeller vanes towards the discharge port. As the bubbles of vapors are transported into this higher pressure region, they can spontaneously collapse in a damaging process called cavitation. So, in a suction is having vapor, it will create vapor lock and leads to cavitation. Cavitation also results in vibration and noise in the pump, placing greater strain on the drive shaft and other components, and also in downstream pipe work. This can lead to greater maintenance costs and a higher incidence of pump failure. NPSH is normally considered in two forms: NPSHR, NPSH required, and NPSH, NPSH available. NPSHR is a pump property. Net positive suction head required is quoted by pump manufacturer as a result of extensive testing under controlled conditions. NPSHR is a minimum suction pressure that must be exceeded for the pump to operate correctly and minimize flashing and cavitation. NPSHA is a system property. Net positive suction head available is calculated from the suction side system configuration. It is essentially the suction side pressure less the vapor pressure of the pumped fluid at the point. NPSHA must exceed the pump's NPSHR rating or the chosen operating condition to ensure the cavitation is avoided. The NPSHR is given by the vendor in the vendor manual. We have to keep the NPSHA more than the NPSHR, yes, by means of keeping sufficient level in the tank from which the fluid is or liquid is pumped as our suction is connected to the pump. Now we can see the source of air in pipelines. Air present in the pipe due to the first time startup or startup after maintenance. When the pump is started for the first time or after some maintenance, breakdown maintenance or running maintenance, we have to check the air present in the pipeline. Air release from solution at sufficiently low pressure. If the priming is not proper, air is not released proper, air will be present in the suction line. Air that enters the pipework due to insufficient seals and or faulty connections. There is any leakage or any flanges are not tightened properly in the suction line, then air entry will be there. Air entering the pipe from a free surface due to an incorrect design and or incorrect operating condition. This air present in the pipeline negatively affects pumps and pumping system, and these negative effects include a reduction in the water cross-sectional area, an increase to the flow resistance, possible loss of prime to the pump if a slug of air is swept into the pump case during a restart, causing a partial or complete loss of prime. The creation of an environment conducive to corrosion. If there is any corrosive liquid like hydrochloric acid is used, and if the suction line is not proper rubber line or FRP material is not used, the HCl will tends to create vapor, and that will corrode the line, and that will naturally create vapor in the line due to corrosion. Creation of turbulence and air entrainment. Imposition of entrained air due to increasing pressure at the eye of the impeller causing damage identical to that of cavitation. For boiler feed water pumps, which get suction from deaerator situated at a higher elevation, more than 7 meter, 10 to 15 minutes normally it is kept. NPSHA to avoid vapor lock and cavitation in the boiler feed water. As the boiler feeder temperature will be more than 105 degrees centigrade, as it is coming from deaerator, where oxygen is removed, chemical and mechanical degradation is done, then at atmospheric pressure 105 degrees centigrade, water will quite naturally get vaporized. So to give sufficient suction net, it is kept at a higher elevation. The suction net avoids the vaporization of the boiler feed water, as the boiling point of boiler feeder will be more than 105 degrees centigrade. The boiling point will be increased as it is kept at the height of 10 to, more than 10 to 15 kept at 10 to 15 meters. Also, deaerator pressure is having minimum 0.35 to zero point 0.4 bar. So the suction pressure will be more than 1.4 bar and gauge pressure. So vapor lock is avoided. Thereby cavitation is avoided in boiler feed water pumps. Cavitation occurs in a fluid flow system where the pressure of liquid starts falling below its vapor pressure, due to which the liquid starts boiling and bubbles are formed. When these bubbles are exploded, they erode the surface of the system. This phenomenon is known as cavitation. Trapped air in pipelines can be hydraulically transported along the length of a pipeline through valves and fittings depending on the pipeline flow rate and fitting geometry. A concentric reducer with the correct flow rate and geometry will allow air to be hydraulically transported through it. This is the concentric reducer, air trapped within the pump inlet piping. If the geometric length of the reducer is sufficient, the air trapped will be transported and it will be removed through the discharge vent by priming. The hydraulic transportability of air refers to the ability of a liquid flowing within a conduit to transport free air in the direction of the flow. This free air is then normally transported within the conduit until it reaches an air wall where it can be mechanically removed, or until it reaches the end reservoir, or until it reaches a position within the conduit where the fluid cannot transport the free air any further. The minimum fluid velocity required to transport free air within a conduit is referred to as the critical velocity. This is the eccentrical reducer. When the air is transported, this can be removed easily through the air vent during the priming. This is called transportation of air. This cannot be traveled further to the discharge if it is removed properly in the priming. The minimum velocity of water will be around 0.9 to 2.4. Normally it will be maintained at 1.8 meter per second in the pump section. This is the concentric reducer and this is the eccentric reducer. This is a schematic diagram of the pump with the positive and negative head. NPSH available is equal to pressure atmospheric plus static head, or pressure plus or equal minus friction lead loss in the suction side to the pipeline and friction, and vapor pressure of the water should be more than NPSHA should be more if the level is maintained sufficient in the positive head, then it will be avoided. For negative sections, it is primed properly and it should be less than theoretically 10 meter, but practically should be less than 8 meters, the negative section pump, to avoid vapor lock. And this is a positive head due to the static height of the water level or the liquid level in the tank, storage tank, where it is suction is connected. This is a positive head static head. Energy loss occurs due to friction in the pipework or within the fluid. This is due to the bend and pipeline. Friction layers will be there. NPSH or energy loss occurs within the pump inlet. This NPSH charge. This NPSHA should be more than NPSH required. And in the pump discharge, the static will get added and it will get a more pressure. So discharge pressure. This is measured in meter of water column. It is the energy available to move the fluid, which is mentioned as head of water column. meter of water column and the name board of the pump. And with the negative section, this is a negative head to the negative section below the pump section line. This is it should be pump section should be practically less than 0.8 meter, less than 8 meter. Then this is the energy required to move the pump. So when the pump is running and the pump is primed properly and the section height is less than 8 meter, then this this length is avoided, negative head, so we can be able to get the energy available to if the fluid and pump can run properly after the priming. This is a schematic diagram of concentric reducer and eccentric reducer. This is the length of the reducer. Concentric reducer is the diameter before reducing the length dia, and this is the diameter after the reduction of the dia, and we can see the angle a tangent is equal to this diameter minus this reduced diameter divided by 2 divided by the total length of the reduced surface. And it is geometrically arranged, then the transportation of air is properly achieved and we can remove the air through priming. And this is eccentric reducer, and this is diameter is reduced gradually, and this is T1 minus D2 divided by the length of the diameter for the eccentric reducer to get the angle of the reducer. Here, and the liquid or fluid or water is admitted, first it will fill this area and the air present in this area will be removed, then it will fill and then it reaches the eye of the impeller, so air lock is avoided. If the pump casing becomes filled with vapors or gases, the pump impeller becomes gas bound and incapable of pumping. So energy impart on air is much lesser. So impeller cannot impart enough energy to air to go out of casing and suck water to water. So priming is compulsory for in case of centrifugal pump. This is why centrifugal pump required priming, because air tend to go to casing while vacuum is created then when pump is sucking the water through suction line. Pump priming is a process of removing air from the pump and suction line. In this process, the pump is being filled with the liquid being pumped, and this liquid forces all the air or gas or vapor contained in the passageways of pump to escape out. Priming may be done manually or automatically. Normally, centrifugal pumps need priming, and fast displacement pumps, rotary pumps or reciprocating pumps does not require priming. It is a self-priming pump. Before starting the pump suction, valves are to be opened fully for a positive suction, and air is to be released through vents from casing and discharge line until full flow is achieved in the vent. Then close the vents and start the pump slowly. Then open the discharge valve slowly to full open after pump discharge pressure is fully developed. For negative suction pump, fill the water through discharge vent to the pump suction until water flow stops. Close the vent, remove the water hose, then start the pump and check if required pressure is developed. Then open the discharge valve slowly to full open. This is the priming procedure mechanically or manually for negative suction pump and positive suction pump for centrifugal type pumps. Now we can see the reducer selection, conditions for the selection and reasons for reducer selection. Concentric reducer is selected, and the suction pipeline is vertical that ensures no air accumulation. So the installations where there is no potential for vapor accumulation, then concentric reducer proper geometry can be chosen and it ensures no air accumulation in the suction line. Concentric reducer also can be selected when minimum straight length of the pipe are required. It will ensure disturbance-free flow. Extended reducer are selected where horizontal installation where air accumulation is possible. If the air accumulation is possible, then extended reducer is required. That will allow transportation of air, which can be removed in the discharge line during priming. Eccentric reducer with the flat section on the top is selected. That will allow the transportation of air. Eccentric reducer is used where the minimum straight length of pipe are required. Then eccentric reducer will help to disturbance free section flow. No vapor lock and no cavitation will be formed. Eccentric reducer can be used with the flat section on the top for suction pipe entering in a horizontal plane. That will allow the transportation of air, and flat section on the top section pipe entering from the below allows the transportation of air. So that will avoid the vapor lock or air lock, thereby cavitation. Most probably eccentric reducers are used. Hope you might have understand the important requirements of the pump operation. NPSH available, NPSH required from vendor, priming, cavitation, and about the selection of reducers in this episode. Do not forget to subscribe and share with your colleagues and friends. Put your likes and comments in the comment box. See you in the next episode. Thank you very much.